Good afternoon, greetings to you. My name is Morgan Pediachi. I'm the head of innovation at Randwater, and I'm very excited to share this platform with you today on this very important and contemporary topic on active leak detection. And here we are basically using satellite technology to detect leaks on drinking water pipelines. We at Randwater, we have moved away from linear thinking, and we have an exponential mindset, and it's all about leveraging the use of exponential technologies to disrupt our value chain, to create greater efficiencies and effectiveness. So just a quick word about Randwater. We were established in 1903. We're a bulk water utility based in Gauteng, more specifically Johannesburg. By volume, we're probably the biggest utility in the world, supplying approximately 5 billion liters of high quality drinking water on a daily basis to some of the biggest metros in Gauteng, including the city of Johannesburg, Ekurhuleni, where OR Tambo is, Tshwane Metro, and then some mines and farms directly as well. So, you know, we're a bulk water utility. We abstract water from the integrated Vaal River system, and we have a pipeline network of approximately 3,500 kilometers of steel pipelines, large diameter steel pipelines, varying from 400 millimeters in diameter to about 4 meters in diameter. So we pump water over long distances, and so there's a significant cost of energy and chemicals associated with that, and therefore we need to preserve these little resources that we have. So just in terms of, I'm the head of innovation, and some of our key thematics are highlighted on this particular slide, but related to this particular project, it's related to smart grid technologies, data analytics and sensors, satellite technologies, artificial intelligence, pipeline asset management, and skills of the future. The objectives of this particular pilot project was, we are aware of some of the deficiencies associated with current leak detection technologies in the market, and therefore we wanted to identify solutions that are non-interruptive and non-disruptive, and therefore satellite technologies was one of the obvious choices. We also wanted to find a cost-effective solution, noting the high cost associated with active leak detection, and we of course we didn't want to disrupt our operations. So we wanted 24/7 operations, so whatever technology we used was not going to interfere with our operations. This particular project was conducted over a pre-selected area of our network, a troublesome, problematic area of 500 kilometers of pipeline. You know, the results were used and compared to existing technologies in the market. It was in an open tender process, and we collaborated with the awarded service providers, namely Innosat, in collaboration with Utilis, based in Israel. The project timelines, we had a kickoff meeting on the 8th of November 2019, and you know, the satellite image was acquired very quickly, and by December 2019 we had a complete leak report. Due to COVID-19 pandemic, we were unable to go to site until June 2020. So, you know, 500 kilometers of assessment was completed within a very short space of time. The methodology was very simple. We had what's referred to as a area of interest, that's your AOI. So the satellite orbits over South Africa and Gauteng, and you know, we provided the area of interest for the synthetic aperture radar technology to actually capture the area of interest. We applied radiometric corrections with the service provider, and this basically facilitated the removal of buildings and swimming pools and agriculture and trees and any other hydraulic structures. And then this is where the magic takes place with the patented algorithm by Utilis, which is able to detect the specific dielectric properties of drinking water as it interacts with the soil. The results were basically transferred and transferable to any smart device on a GIS network or platform. So this was the area of interest that we covered, and we pre-selected a certain number of leaks, potential leaks, for validation. What we found through this particular project was that the service provider indicated that we had 40 leaks detected in this 500 kilometer section. We randomly selected 30 leaks, and we went to site with our operators and engineers and scientists, and we were able to have 100% validation of the leaks that was referred to as potential leaks. The financial savings from this particular study was calculated. Of the 40 leaks, we just basically provided you with the cost savings on 2 of the smaller leaks in excess of R1 million per annum, which indicates the real cost savings associated with this particular technology. Here are some of the videos. This was one of the bigger leaks in an underground chamber. We were able to pick up this leak on our A8 pipeline using satellite technology. It's a big leak. We were able to pick up smaller leaks on a reticulation network pipeline adjacent to the Randwater pipeline. And that was confirmed as a leak, a small leak. So the conclusions from this particular study is that the use of satellite technology to detect leaks on drinking water pipelines has been demonstrated, validated, and approved for use at Randwater. We were able to capture a very large area. In one day, you can actually capture the entire South African pipeline network in one day. And then you apply the algorithm, and the process of analysis takes a few weeks. We had a very quick turnaround time, 100% validation rate, and great cost savings when compared to other acoustic-based technologies in the market. So we were able to confirm savings of water together with enhancing our revenue, which was part of our primary and secondary transaction drivers. Thank you very much.